Morning, my dear students. 8th Standard Science 1, Term 2, Unit 5, Electricity. Previous class, we have discussed electroscope, gold leaf electroscope, lightning and thunder. Today class, we are going to discuss about earthing, lightning arresters, electric circuits and series circuits. Okay children, let us move to the lesson. What is earthing? What is earthing? The term earthing means the correction of the neutral point of the supply system or non-current carrying parts of electrical apparatus such as metallic framework, metallic covering of cables, the earth terminal of circuit outlet, stay wire, etc. To the general mass of earth is such a manner that all times immediate discharge of electrical energy takes place without danger. Grounding a negatively charged electroscope involves the transfer of electrons from the electroscope to the ground. Once all excess electrons have been transferred to the ground, the electroscope is neutral. Next, we are going to discuss about clearly explanation of earthing. A safety measure devised to prevent people from getting shocked if the insulation inside electrical devices fails is called earthing. Electrical earthing can be defined as the process of transferring the discharge of electrical energy directly to the earth with the help of low resistance wire. We get electrical energy from different sources. We get electrical energy from different sources. Have you seen the picture, children? Hydroelectric power station, wind energy, wave energy, coal power. So the battery is one such source. We use it in wall clocks, cell phones, etc. For the working of refrigerators, air conditioners, washing machines, televisions, laptops and water heaters, we use domestic power supply. Usually an electric appliance such as heater and iron box, etc. are filled with three wires, namely live wire, neutral wire and earth. The earth wire is connected to metallic body of the appliance. This is done to avoid accidental shock. Suppose due to some defect, the insulation of live wire inside an electric iron is burnt, then the live wire may touch the metallic body of the iron. If the earth wire is properly connected to the metallic body, current will pass into the earth through earth wire and it will protect us from electric shock. So what is the use of live wire? If the earth wire is properly connected to the metallic body, current will pass into the earth through earth wire. It will protect us from electric shock. The earth being a good conductor of electricity act as a convenient path for the flow of electric current that leaks out from the insulation. So, three types of wires are there: wire, neutral wire, and earth. This is known as earthing. Next, we are going to discuss about lightning arrestor. So, what is lightning arrestor? Lightning arrestor is a device used to protect buildings from the effects of lightning. Lightning conductor consists of a metallic lightning rod remains in air at the top of the building. Major portion of the metallic rod and copper cable are installed in the walls during its construction. The other end of the rod is placed into the soil. When lightning falls, it is attracted by the metallic rods at the top of the building. The rod provides easy route for the transfer of electric charge to the ground. In the absence of lightning arresters, lightning will fall on the building and the building will be damaged. So, the lightning arrestor is a safety device during rainy season. During rainy season, the lightning and thunder, we can see lightning and we can hear thunder. See the picture of simple lightning rod, earth down conductor, that is copper strip, check terminal, crossfoot, earth lead. The connection of lightning arresters in the building. Next, we are going to discuss about lightning protection system. Simply, we can say LPS. A lightning protection system provides a safe pathway for energy from a lightning strike to find its way to earth, encouraging the bolt bypass building components that might otherwise be damaged. So its job is both to provide a path for the lightning strike to reach ground and to avoid damaging the building as the electrical current of lightning bolt flows through the protection system components. Next we are discussing about electric circuits. We saw that when two oppositely charged spheres are connected by a metallic wire, electrons flow from sphere which is at low potential to the sphere at high potential. Simply if two terminals of a battery, one is positive and the another one is negative, which are at different potential are connected by a metallic wire. Electrons will flow from negative terminal to positive terminal. The path through which electrons flow from one terminal to another terminal of the source is called electric circuit. Electric circuit path for transmitting electric current. An electric circuit includes a device that gives energy to the charged particles constituting the current such as a battery or generator. Devices that use current such as lamps, electric motors, or computers, and the connecting wires or transmission lines. A simple circuit consists of four elements, that is, a source of electricity, battery, a path or conductor through which electricity flows, that is, conducting material is here copper wire, a switch to control the circuit, on off switch, and the electrical resistance, that is, lamp, which is any device that requires electricity to operate. The above figure shows the simple circuit containing a battery, two wires, key, and an electric bulb. The source can be a battery or electric outlet in your room. The electrical resistance refers to the device that consumes the energy. Control means here key is the mechanism that is used to start, that means on switch, stop, that means off switch, and regulate the electric current. When the key is on, electrons flows through the circuit from the negative terminal through the wire conductor. So the electrons flows through the circuit from the negative terminal through the wire conductor, then through the bulb, and finally back to the positive terminal. The light glows when current is flowing through its filament. So the electrical energy is converted to heat energy. The filament is heating after the bulb will glow. So the electrical energy is converted to heat energy. The heat energy is converted to light energy. There are two basic ways in which we can connect these components. They are series and parallel. Two types of connection is there. One is series, another one is parallel. Next we are going to discuss about electrical eel. Electric eel, it's producing its own electricity. Now we are going to see the electric eel structure. Is a snake-like body, contains electric generating organ, brown skin with tan spots, vital organs located in front of 20% of body, small eyes, gill cover, anus toward front of body, skin has tiny scales, elongated anal fin. So this is the eel, it's producing electricity. This is the eel, it's producing electricity. Electric eel gets its name from its shocking abilities. Special organs in the eel body release powerful electric charges of up to 650 volts. The electric eel gets its names from its shocking abilities. Special organs in the eel's body release powerful electric charges of up to 650 volts. Electric eel is a species of fish which can give electric shocks of up to 650 watts of electricity. So, electric shocks of up to 650 watts electricity, but if the eel repeatedly shocks, its electric organs become completely discharged. then a person can touch it without being shocked. Next, electric circuits is two connections are there. One is series, another one is parallel. Now we are discussing series connection. A series circuit is one that has more than one resistor, but only one path through which the electrons can travel. From one end of the battery, the electrons move along one path with no branches through the resistors. Resistors means here bulbs to the other end of the cell. All the components in a series circuit are connected end to end. So, current through the circuit remains same throughout the circuit, but the voltage gets divided across the bulbs in the circuit. In the following series circuit, two bulbs are used as resistors. In this series circuit, charges, that means electrons, from the battery have only one path to travel. Here, battery, key and two bulbs are connected in series. Charges flows from the battery to each bulb at, at a time in the order they are wired to the circuit. If one bulb in the circuit is unscrewed, the current flow to another bulb would be interrupted. So we put serial lights during festivals. If the lights are in the series circuit, we put serial lights during festivals. If the lights are in a series circuit, one burned out bulb will keep all the lights off. If the number of bulbs in a circuit with the battery increases, the light will be dimmer because many resistors are acting on the same power from the battery. So we saw that in series circuit, same current travels through every resistance and the voltage will be different across each resistance. Let us consider three bulbs connected in series. Let I be the current through the circuit and V1, V2, V3 be the voltage across each bulb. The supply of voltage V is the total of the individual voltage drops across the resistance bulbs. So, total voltage is equal to V1 plus V2 plus V3. So, what is series connection? In a series connection, the current is the same through each component regardless of what components are used or their values. The voltage drops across each component in the circuit are dependent upon the values of the components used in the circuit. Thank you, children.